The objective of this lesson is to summarize how the graphs of radical functions are affected by different parameters. So let's take a look first of all at our general look of an equation with a radical in it. So you're looking at the a in front. If you recall, the a in front will stretch or shrink it. So usually that means it's going to stretch it this way or shrink it this way. And the index here, this is where we're going to talk about the even and the odd patterns that we have. The number on the inside, I'm going to make sure that you recognize this part. So when you look at the number on the inside, this is where we work with our horizontal shift. And this one is where we get our vertical shift. That's very standard for functions, that inside the function itself, inside the radical in this case, affects it horizontally, whereas the number outside of the function affects it vertically. So if we're looking at an even index, so for instance a square root or a fourth root, if we don't have any shift to it, the general look of it is there's a starting point here and it goes in that direction. If you do have a starting point, it shifts it over h units and up h units or down k units, excuse me. So the h units is side to side, the k units would be up and down for it. Whereas the odd index, it has a turning point where you go from this increasing value and then it starts to slow down at that turning point. So we're going to call this the turning point. And that's affected by the HK is where the turning point is. Okay, and then on the even index, this is the starting point. Now, just to give you a little more information, just that will help you on this. You'll put down here the A in front here. The A will stretch or shrink. One more important piece of information. If that A is a negative, it's going to flip it over the x-axis. Okay, so if negative, it's going to flip it vertically. Now it's going to be affected by where the starting point and the turning point is, but basically it flips it over so that it looks like that, and this one it flips it over so it will come in and out from that one. All right, so your steps, the first step, if it's even, you find the starting point. And if it's odd, you find the turning point. That's all related to the h and the k up here in the general form. The second step is you use a calculator to come up with points to get the shape. That's to help you see how much it shrinks or it stretches. So use a calculator table for precise points. Now, if you're just doing a sketch, you don't need to do that, but if you're trying to get a precise graph, you want to make sure you use your calculator to get that. So let's look at some examples here. This first one has an even index, so we're going to look for the starting point. The starting point for this one is going to be the opposite of that, so -10, and the same as that, the 30. That's the opposite because we want x minus something. X minus a -10 is what that starting point is. So it's the opposite of what's inside, the same as what's outside. So let's go ahead and find our starting point on the graph. So we're going to go out here, I'll go by 10. So here's a -10, and I'm going to go up to 30 here. So there's that point there. Now, I want to go to my calculator to get a table of some values. The graph is generally going to go up in this direction, but let's get a little more precision to it by getting some points on it. So let's go ahead and enter it into our calculator. So if you want to do a sixth root here, we're going to go to our math menu, go down to the xth root, and then it will ask you to put in the sixth root. I'm going to put in then x plus 10. And then I'm going to go out of there and just add 30. Now, that sixth root is really going to pull it down. The higher the root, the more condensed it's going to be because it's taking a root of something, going to bring the number down quite a bit. And so when we look at the graph, if you just take graph, you won't see anything because it's starting at -10, 30, it's up too high. So we got to change our window here. We'll change our window, we'll keep the negative, let's go maybe -15 because it starts at -10 here. And then let's go y max, let's start up at, or let's go all the way up maybe to 40 and see what our graph looks like. So there it is, very flat. Now let's go ahead, and if we wanted to see how opened up it is a little bit, you'd have to bring your y values up a little bit to see it, but because of that sixth root, it's very flat. It's still curved, but it's very flat. So let's get some precise numbers here. So on my graph, I'm going to start with -10, 30. That's my starting point. So let's go ahead now and take a look at some other points on the table. So second table, I'm going to go up here to -10. Notice -10 is at 30, -9 is at 31. And then after that, it's going to be very flat, so the numbers don't change a whole lot. So I'm going to get another number out here in the positive range. Let's go with, looks like it's about, at 1, it's about 31.5. That shows me how flat it is. So here, I'm only going to go at -9, I'm going to go just a little bit above it, here at -9, and then it's going to stay really close to 31. So out here at 1, I'm going to be up just at 31.5. So that shows you how flat this graph is. That helps you see the shape of it. So the higher the root, the flatter the graph. It still curves, but it's going to be very flattened. If you were to make this into a square root, it would start arching up a little bit more from there. Okay, let's look at another graph here. Let's do the cube root here. Let's find our turning point since it's an odd. So our turning point is at 4, 8, -8. So the opposite of that, same as that. So if we go out here to 1, 2, 3, 4, so there's 4, and then we go down to 1, 2, 3, 4, 5, 6, 7, 8. There's -8. So here's where my turning point will be on the graph. Let's put that, since it's a turning point, we're going to put it in the middle of the table for when we do it. Let's enter that into our calculator. So if we go to y equals, I'm going to clear this one out, and I'm going to do a cube root. So if I go to the math menu, I can go down, there's a cube root, and I'll do x minus 4, and get out of the cube root, and then subtract 8. And now I'm going to look at, again, if I hit the graph, remember I changed my window, so I'm going to go ahead back and hit zoom standard to get to my standard graph. So notice that I'm down near the bottom of the graph here, which I can see it pretty well, so I'm okay with how the curve shows up here, and curves into it and then curves out. Let's go ahead and look at some other values on the table. We're going to go to the left of 4. So let's go with maybe 1 and -9.4. And we had at 3, we had, I believe, -9. Let's confirm that. So at 3 we had -9, good. And now we're going to go up above it. So at 4 we had -8, at 5 we had -7. And then let's go a little further out just to get some of the shape of this one. So let's go out to maybe to 10. And so at 10, we're going to go at negative 6.2. Okay, so we're going to try to see what that graph looks like. So at 1, we're at negative 9.4. So down here. At 3, we're at negative 9. So it's going to curve like this into it. And then out of it, 5 at negative 7. So negative 7's right there. And at 10, so there's 5, so this would be at 10. We're at negative 6.2. So negative 6.2 is right about there. So it's going to curve out of it like that. So we get the shape of how condensed it is by getting some other points and graphing them on the table. So when you do these, just a reminder, the general shape, if it's an even index, it's going to be just that one curve coming out of it. You find the starting point. Then look to your table on your calculator to get some more points. If it's an odd index, that point that we find from H and K is the turning point. So you want to get points from your table on both sides of it to get a very precise graph.